Welcome to the video on translations. Why don't you go ahead and make sure you're turned to this page in your notes packet, and in order to complete this section on translations, you're also going to have your compass and your straight edge handy. Remember that a translation is going to be a rigid motion that slides an object a fixed distance in a given direction. And even though I just said that really fast, we're going to slow down a little bit and analyze what this means, because this is important. I'm going to think about a translation maybe as a piece of paper that's sitting on a table. And if I take and I slide that paper across the table, I'm actually translating it. I'm sliding that paper some distance, and that's our fixed distance, and then some direction, whether it's right, left, up, down. But where it starts and where it finishes, that's what determines our translation. A translation is an example of a direct isometry. So I'm going to take a look at what we mean when we say direct isometry. So if I'm taking this triangle, and maybe for lack of something better, I'm going to call it triangle ABC, and I want to take and translate or slide my triangle across the paper, I might end up with a triangle A prime, B prime, C prime. Now, because the orientation on this original triangle is clockwise, and the orientation on my new triangle is clockwise, that's what makes this guy direct. So direct means same orientation. And when we say isometry, we mean preserves or keeps the same length or distance. So in other words, the distance between points A and B in the original is going to be the same as the distance between A prime and B prime in the image. Distance between point B and C in the original is going to be the same as the distance between B prime and C prime in the image. And then lastly, of course, the distance between points A and C in the original is the same as the distance between points A prime and C prime in the image. Now, notation sometimes for translations can be a little bit tricky. So we're going to use this capital T that represents translations. Mathematicians aren't always real original when it comes to notations. And then this first number here tells us the horizontal change, or the change that's going to be made along the x-axis. The second number in the ordered pair tells us the distance or the number of units we're going to move up or down, or in other words, the vertical change. Another way we can show the same notation is to show starting at a point with coordinates x, y, and moving it plus a in the horizontal distance and plus b in the vertical or the y distance. And then yet a third way that we can show this exact same notation is to use these special pointy parentheses. And then the first number in the parentheses, of course, refers to how much change there's going to be in the x, or the horizontal distance. And the second number in the parentheses tells us how much change there will be in the y, or the vertical distance. It's important to note that all three of those mean exactly the same thing. We're also going to talk about translation using vectors. And down at the bottom of the page, they give you a translation on the coordinate plane, and they're asking what vector describes the translation seen in this set or on this set of axes. And I guess before we can tell the vector, it's important to know what a vector is. Simply put, a vector is an example of a directed line segment that has both length and direction. Notice that this corresponds very nicely to the definition of translation up at the top of the page. We said that a translation moves something a fixed distance. Well, the fixed distance would be the length. and in a given direction. So that's why we use vectors in order to describe translations. All right, if we take a look at our picture on the coordinate plane right now, we've got this purple triangle, ABC, that through some vector, some translation, ends up at triangle ABC prime. Well, if I take a look at where we started in the original at point A and where we ended up in the image, point A prime, and I draw the line segment between the two, that guy would represent the vector that moves or shifts point A onto point A prime. This particular vector will take point A 4 units in the x direction, or move it 4 units to the right. And then once it moves it 4 units to the right, we'll move it 1, 2, 3, 4, 5, 6, 7, 8, 9 units down. So a translation using vector A prime can also be represented as a translation that moves an object 4 units in the x or the horizontal distance, followed by -9 units in the y direction, which we might also say takes a point with coordinates xy and adds 4 to the x value and subtracts 9 from the y value. We might also say this translation, or this vector, moves a point 4 units to the right, 9 units down. So these are all ways of saying exactly the same thing. So we've got a lot of different ways to notate the exact same vector. One thing that I do want you to pay attention to or notice in the picture is that if we draw in the vector that maps point B to point B prime, and we take a closer look at it, we notice that it also will move or shift each point 4 units to the right and 9 units down. And similarly, if we look at the vector that will map point C onto point C prime, we notice that this guy too takes and shifts each point 4 units to the right, 9 units down. Now take a look at those vectors, A to A prime, B to B prime, and C to C prime. Looking at the picture on the coordinate plane, what do you notice about each and every one of those? Hopefully you answered that these 3 vectors are all parallel to each other, because that's kind of an important thing to notice. All right, we're going to go ahead now and we're going to talk about translating not on the coordinate plane but in plane space. I'm going to skip these steps up at the top of the page because I'm going to show you a way to do the translation in a slightly easier, or what I think is a slightly easier way. But before we do that, in the examples it says draw the vector that defines each translation below. I'm going to say let the solid figure be the pre-image. And the pre-image, remember, would be whatever it is that you're starting with. You know, I probably couldn't do that again if I wanted to. So that's my pre-image. And I'm going to say, let's let the dotted one be my image. So that's where I end up after the translation is performed. So it says draw the vector that defines each translation below. You simply have to take or find any point that you want in the pre-image, so in the original before it gets translated. Find the corresponding point in the image, and then draw the vector that connects the two. So that would be the vector that shifts each and every point in the pre-image onto the image. If I think about this solid guy in the second one as being my pre-image, take and pick any point in the pre-image, doesn't matter which one. The key is you have to take his corresponding point in the image, and then use your straight edge and go ahead and sketch that vector in. And the last one is the same idea. Take any point in the pre-image, find its corresponding point in the image, and you can use your straight edge and draw in that vector. And again, it doesn't matter which point you pick in the pre-image and which point you pick in the image. As long as you connect corresponding points, the vector will always be the same size in the same direction. All right, let's get to the part that I know you've been waiting for. Grab your compass and we are going to go do a construction. So it says, use your compass and straight edge in order to apply the translation of vector AB to the segment whose endpoints are P1 and P2. So the way that I'm going to start this is I'm going to go ahead and use my compass to measure the length of vector AB. I know that when all is said and done, I have to translate or move or slide P1, P2 a distance that's equal to the length of vector AB. So that's my first step. Go ahead and measure the length of this guy. I'm going to do this very carefully and very precisely, and as I'm doing this here, you should be doing this at home also. So once I've measured the length of my vector, what I'm going to do is, using that same compass setting, I'm going to go put the point of my compass at point 1 and draw that same circle, or a circle with that same radius. And then I'm going to move my compass down to the second endpoint and repeat. Do exactly the same thing. What that tells me is every point on those purple circles is the same distance away from those endpoints as vector AB is long. Okay, step 2. I'm going to use my compass as my measuring instrument, and I'm going to go measure the distance from point A to point P1. And as I'm doing this in the video, you should be doing this too with your compass and straight edge at home. If you need to pause or stop or rewind the video, don't be afraid to do that. Please remember that we're trying to do this, or you're doing this with the idea of understanding in mind. So if you need to pause it and rewind it in order so that you can understand, please, please, please definitely do that. So I'm going to measure that same distance. And again, I'm going to do this very carefully and very precisely. And then, keeping that same distance, I'm going to move the point of my compass to the end of my vector because I want to translate. I want to slide. And I'm going to construct that arc. And then I'm going to go do the same thing from point A to point P2. And this is going to be a different compass setting, so I'm going to change the color. I'm going to have to stretch out my compass a little bit longer for this one, and you will too. And again, I want to think about this as translating or sliding, so I'm going to slide my compass from point A down the vector to point B, and I'll construct that arc. So these 2 points right here reflect what you get when you slide point P1 and point P2 by vector AB. I'm simply going to go ahead and take my straight edge now and go connect those. And I've successfully translated P1, P2 by a vector with length and direction of vector AB. All right, at this point, if you have questions about anything I said, jot down a note to yourself in the margin. Remember to ask me about it the next time that you come to class. As always, thank you for the gift of your time. Hopefully you've learned something and made good use of that time so that you've been productive and put that time to good use. And I will see you next time you come back to class.